Okay, welcome back. In this video, we're going to look at some additional straight line concepts, and we begin with the concept of distance. And here we mean the distance between 2 points. So we have points P and Q located in our XY plane. Point P is said to have coordinates x1, y1, and the coordinates for Q are x2, y2. So what we're trying to find is this straight line distance, which I'm going to label D, between the points. And you can see that the way we do this is to first construct a right triangle like this. And in so doing, we now are able to label these side lengths right here of the triangle. These are called the legs of the triangle. So what would the length of this side be here? Well, it's actually the run, and it's the distance between x2 and x1. So it's the change in x, and it's given by x2 minus x1. And what about this side length here in the triangle? Well, this side length here is given by the change in y, and therefore it is y2 minus y1. And once we have those two lengths, of course, we can find D by using the Pythagorean theorem. And it is D squared is equal to x2 minus x1 all squared plus y2 minus y1 all squared. And from that, we take the square root of both sides, and we have this equation for the distance between any 2 points. Okay, so I just wanted to show you that the formula is easily derived once you draw the diagram and label the two legs of the triangle and use the Pythagorean theorem to calculate D. So now we can do this question here. Determine the distance between these points. So I will use, this first point is like my P, so I'm going to call it x1, y1. And here, this will be my Q, so it's x2, y2. And now we're just going to use the equation for D. And actually, to save myself from making this square root sign, I'm going to be solving for D squared first. So what I need to do is simply in here, x2 minus x1, and in here, y2 minus y2 minus y1. So first, x2 minus x1. So that is 3 minus a negative 2. 3 minus a negative 2 will be in that first bracket. And then in here, I want to do y2 minus y1. So that's negative 5 minus 4. Okay, so now what does that give us? Well, inside this bracket now, 3 minus a negative 2 is the same as 3 plus 2. So now I have 5 squared here. While in this bracket, negative 5 minus 4 is negative 9, like this. So D squared then is 25 plus 81. Now, whenever you square a negative number, of course, it'll come out positive, but watch, if you're using your calculator, -9 squared like that, that's going to give you the incorrect answer because this answer is -1 times the square of 9. So it'll say -81. When you want to square -9 correctly with your calculator, you need the bracket. Okay, like this, -9 squared. There you go, 81. So what we have now is d squared is equal to 106. And therefore d is then the square root of 106. And here, let's just get an approximate answer for this. So the square root of 106 is roughly 10.3. Okay, so that's an example of using the distance formula to find the straight line distance between 2 points. Okay, the next example is angle of inclination. So like the name suggests, it is the angle at which the line is inclined. So in our diagram, actually it would be right here. Okay, so that's the theta that we're calculating. And how can theta be calculated? Well, the tangent of theta is equal to the slope. How is that possible? The tangent of the angle, remember, is the opposite side length over the adjacent side length. So yeah, it's true. The tangent of the angle is the side length delta y over the side length delta x. Or it's y2 minus y1 over x2 minus x1. Okay, and that definitely is the slope. So this relationship holds true, and the diagram shows you that. Okay, and by definition, the angle of inclination is the smallest positive angle a line makes with the positive x direction. Now, there are only two possibilities since we are measuring a straight line, and with respect to the horizontal, the possibilities are that theta is in quadrant 1 or theta is in quadrant 2. And those are the only possibilities for the line at which the angle at which a line is inclined. Okay, so we're going to do one example of each, okay? So when the slope is positive, expect a quadrant 1 angle. When the slope is negative, expect a quadrant 2 angle. Okay, so here we go. The slope is 0.6. So what does that mean? It means the tangent of theta is 0.6. So how is theta obtained? By taking the tangent inverse of 0.6. All right, so with your calculator, you remember how this goes. Shift, tangent, 0.6, and there we go. That's our angle. Okay, now actually we were only given one significant digit here, which means that we would, if we used our trigonometry rounding table, when you have only one significant digit, you should round your angle to the nearest 10. So rounded to the nearest 10, this would be roughly 30. Okay, because this is the tens column and you look to the 0 beside it. So if we were to use our trigonometry rounding table, this actually would be roughly 30 degrees. Okay, now we're going to look at one where the angle is negative. But what we can do is the same way we did in our trigonometry unit. First, we can find the reference angle alpha by using the absolute value. So use positive 1.8 here to calculate alpha. So we do the tangent inverse of 1.8 with our calculator. All right, and we get this. Now we've got 2 significant digits this time. So I guess I'll round to the nearest 1. So this is roughly 61 degrees, but that's not our final answer. Because we would have to say where is tangent negative, and tangent is negative in quadrant 2. And so how do we adjust theta when we're in quadrant 2? Well, we do 180 degrees minus the alpha. So if you do here 180 minus 61 degrees, you will get 119 degrees. Okay, so I did one example where we had a positive slope, and that was much more straightforward. Our answer is in quadrant 1, and in quadrant 2, we just have the absolute value used. And then we have to remember from the cast rule, where is tangent negative? And certainly it's negative in both quadrants 2 and 3, but remember, for our purposes here, only the first 2 quadrants apply. Okay? Okay, so I mean, I can give you a quick sketch to accompany those if that's going to be helpful as well. Like, I mean, a really quick sketch here. So y and x. So for this first one, it's inclined at 30 degrees. So we'll say it like that, okay? So this in here is 30 degrees, and this is the line of interest. And the second one is a quadrant 2 angle. Let's take a peek at that. Okay, so again, 90 plus 30, something like this. Okay. So this angle is the 119 degrees right there. Okay, and the 61 degrees is actually here, the alpha that we calculated first. So there's the 119, and here is the 30. So you can use that to help you understand it as well. Okay, the next concept concerns itself with parallel lines, and you know what this means, right? 2 lines are parallel if they never meet, and these lines will have the same slope. So slope 1 equals slope 2. 2 lines are perpendicular. What does this mean? This means the straight lines meet at 90 degrees. Okay, so parallel. Let me see if I can draw 2 lines that are parallel. Hopefully that's pretty close. Okay, so line 1, line 2. Parallel lines have the same slope. They'll never meet. Perpendicular lines will look like this. Okay, so one line, the other line. So line 1, line 2, line 1, line 2, meeting at 90 degrees. And what is true about perpendicular lines? When you multiply their slopes together, you will get -1. The product of the slopes is -1. Okay, so we can solve a few problems together based on those facts. So this problem says line 1 passes through the points -3, 9, and 4, 4. Line 2 passes through the points 9, -1, and 4, -8. Are the lines parallel? So do they never meet? Are they perpendicular? Do they meet at 90 degrees or neither? What would that represent? That would represent the most common possibility, is that the lines are not parallel. They do not meet at 90 degrees, but they intersect at any other angle other than 90 degrees. So this is actually the most common case. Okay, how will we answer the question? Well, we have to work out the slope of this line and the slope of this line, and then compare the slopes. And the slope, remember, is calculated like this. Rise over run. So we're gonna do that here. And I'm just going to go like this. So x1, y1, and this will be x2, y2, and I'll start with that one. So working out the slope of line 1. So I'll call it M1. Okay, so here we go. We're gonna do y2 minus y1. So 4 minus 9 over x2 minus x1, 4 minus a negative 3. So what does that give us? In the numerator, we will have negative 5. In the denominator, 4 plus 3 or 7. So the slope of the first line is negative 5/7. Now, I'm going to do the same thing for the second line. So I really don't have room to write here, but I'm doing the same exact thing. x1, y1, x2, y2. So first, y2 minus y1. So that's negative 8 minus a negative 1. Denominator, x2 minus x1. So that is 4 minus 9. Okay, so let's see what we have now. This is negative 7 plus 1. Sorry, this is negative 8 plus 1, which is negative 7. And the denominator, 4 minus 9, is negative 5. A fraction with both numerator and denominator negative is the same as a positive fraction. So we now have the slope of the second line is 7/5. So time to answer the question. Are these lines parallel, perpendicular, or neither? These lines are perpendicular. And how do we know that? What is the product of M1 and M2? What is negative 5/7 multiplied by 7/5? It is negative 1. Okay, so this means since, this little symbol, okay, since the product of the slopes is negative 1, the lines are perpendicular. Okay, let's try the second example. Are the lines described by the following equations parallel, perpendicular, or neither? Okay, once again, we need to know the slopes of the lines so that we can compare them. This time we're given the equations. So how can we take these equations, this one, and this one, and from them obtain slope information? Well, we learned this in our last video. We have to write these equations in the form y equals mx plus b, since the slope of the line will be the coefficient of x. So let's work on isolating y. So first I will isolate negative 4y. Both of these items are going to the other side of the equation. Remember, this given form here is called general form. So this will be a negative 8x and a negative 1. But this is the same as saying 4y is 8x plus 1. We just multiply all terms by negative 1. And y is obtained here by dividing by 4. So what do we end up with? The coefficient of x will be 8 over 4, which is 2. So we get 2x plus, what's the value of b, or the constant? It is 1 over 4. So 1/4 or 0.25. Okay, looking at this equation, what is its slope? The slope is the coefficient of x, like this. So slope 1 is 2. Now we're going to do the same thing over here. We have to isolate y. So 4y is negative 2x plus 3. Divide by 4. Like this. What is the coefficient of x? It's negative 2 over 4, which is the same as negative 1 over 2. So we have negative 1/2 x plus, what's the constant or b value? 3 over 4, or 0.75. So what's the slope of the second line? Its slope is negative 1/2. So now, are these lines parallel, perpendicular, or neither? Once again, the lines are perpendicular. How do we know that? We can multiply 2 multiplied by negative 1/2 does indeed give us negative 1. So we know that the lines are perpendicular. Okay, if both of these slopes were negative 1/2, both of them, then we would say that the lines are parallel. Or if both of these slopes were 2, we would say that the lines were parallel. And if the numbers are not the same, and if their product is not equal to negative 1, then we would say the lines are neither parallel nor perpendicular. And that means they intersect at a different angle, or any other angle. Okay, let's do one last question before we conclude here. Determine the slope of a line that is parallel to a second line whose angle of inclination is 60 degrees. Okay, so we can do this 2 ways. I think I might do this one graphically with you. So here's the situation, and I'll do it with just a sketch, okay? So it's not going to be perfect. I don't have a protractor with me because I don't think it's necessary, but let's see what the situation is, okay? So there is a line inclined at 60 degrees. So I'm going to start by drawing that. 60 degrees is something like this, okay? So this is 60 degrees right in here then. Okay, and that is the first line, let's say. Okay, so there's the line inclined at 60 degrees. Now, we want to know the slope of a line perpendicular to this one. So basically, I can just come through the origin and draw a line perpendicular to that one. So perpendicular means So this is my line 2, okay? Perpendicular means that these lines are meeting at 90 degrees. So I'm gonna draw 90 there to show you that line 1 and line 2 meet at 90. And here's the key. At what angle, what is the angle of inclination of this line? Well, remember, by definition, you start at the x-axis and you move around until you hit that line. So it's 60 plus 90. All right, so it's 150 degrees. So, what is the slope of line 2? The slope of line 2 is equal to the tangent of 150 degrees. And then all you have to do is use your calculator to work out what that value is. So the tangent of 150 is this number here. Now, if I were going to be using my rounding table of trigonometry, this is rounded to the nearest 10 degrees. And therefore, I should only have one significant digit in my answer. So this is negative 0.6 roughly. Okay? All right. So that's one way to do that question, is graphically. And the other way to do it, if you didn't like that at all, is to start by finding the slope of line 1. Okay, so this is another way. I'll just put it down here in the corner. The other way to do this is to note that the slope of line 1 will be the tangent of 60 degrees. Okay, and therefore what slope does line 2 have? Well, it would have a slope equal to -1 over the tangent of 60 degrees. Okay, and that's because, right, if m1 times m2 is -1, that means that m1 is -1 over m2. It also means m2 is -1 over m1. Okay, we say that the slopes are negative reciprocals of each other. So if slope 1 is the tangent of 60 degrees, then slope 2 is -1 divided by the tangent of 60 degrees. And look what that gives you. -1 divided by the tangent of 60. Oh, same answer. So this will also give you, once rounded to one significant digit, 0.6. So you can do it this way, which doesn't use a diagram. Or you can do it this way, taking 60, adding 90 to it to get 150, and then taking the tangent of 150. Okay, so thanks a lot. We've added many concepts today, including distance, angle of inclination, and the relationships between parallel lines and perpendicular lines. All right, so please don't forget to check Blackboard for your recommended practice problems. Have a good day.